Okay, so this is lesson 14, radical functions. So let's go on and describe what a radical function is. First of all, radical function is a function of the form f of x equals the nth root of x, where n is a natural number. So we are dealing with the third root, the fourth root, right? The square root, which is an understood 2, right? That would be an understood 2 right here. Okay, that would be what we're dealing with here. And we're going to focus more on not solving the radical equations, but, well, we'll do a little bit of that, but really we're going to be focusing on the functions themselves. Remember, functions tend to have domains and ranges. So that's something we'll talk about here. Okay, the domain and the range of a radical function. So when dealing with the domain, we're going to look at the index, right? So the nth root of some number here. Okay, and so if that nth root, right, is even, if n is even, then the domain is going to be some cutoff number, but in this case, it's going to be 0 to infinity. Okay, and the range, if n is even, will be 0 to infinity as well. Okay, and that's just based on the graph. So the graph, what does it look like? It tends to look like this. Okay, now notice it goes from 0 forever to the right, but it also slowly, it still drifts up, just ever so slightly, it drifts upward. So the range also is 0 to infinity. Okay, so that's if the index is even. If the index is odd, then we'd say that the domain is negative infinity to positive infinity. There's no issue. Okay, if you have a cube root of a number, that number can be negative. Okay, that's perfectly fine. And the range, if the index is odd, is also negative infinity to positive infinity. And that's because it's the other side of the graph, right? So same graph as whenever it's even, except it also has this, you can see the red part there, right? It has a negative region as well. Okay, so it does both. Okay, so let's go to this function here. We're going to ask a lot of questions about it. We're going to work with this function for like half of the lesson here. So first we're going to start off with this f of x equals the square root of 3x plus 1, and we're going to discuss the domain. So square root, although I don't see an index here, I know it's an understood 2 square root, right? Whenever you square something, you raise it to the second power. Okay, so it's an even index, which means it has a cutoff point from something to infinity. Now the question is, what is that something, right? And to figure that out, you need to figure out inside here, there's 3x plus 1. So before I write this out, let me go ahead and just get rid of that. Let's talk about 3x plus 1. It's inside of a radical, so it needs to be greater than or equal to 0, okay? And we've done a little bit of this already, but we're really going to jump in with it now. Okay, 3x plus 1 is greater than or equal to 0. If I solve that, I get 3x is greater than or equal to negative 1. So x is greater than or equal to negative 1/3. I can visualize that on a number line. X is greater than or equal to, so it could equal negative 1/3 or be anything bigger than 1/3. Okay, so that region right there starts at negative 1/3 in a bracket because negative 1/3 is included. It's possible that that's satisfies the equation or the domain, and it goes until infinity. Okay, with a parenthesis on infinity. Okay, so that'd be the domain. I'm going to ask now if the function is even or odd. Okay, so again, the function, just to write it down, the square root of 3x plus 1. I want to determine if it's even or odd. So we did talk about this before and how to determine if a function is even or odd. So here's a little review. Remember, if you change x to a negative and simplify it and you get the original function back, right, it has no impact on the original function values, then you would say that it is even. if changing all the x's to a negative gives you a negative version of the function, we'd say it was odd. Okay, so let's change x to a negative. And let's see what that does to the problem. Well, 3 times negative x is going to be a negative 3x. Okay, and let's compare that to the original. They're not identical, right? They're not the same. -3, +3 inside, so that's not the same. It's also not a negative version of the original, right? A negative version of the original would just be a negative out here. But I have a negative inside and I can't just take it out. So these are not the same and they're not complete opposites as well. So we'd say this is neither even nor odd because neither one of these hold. Okay, here we have the square root of 3x plus 1 again. Let's find the roots. Remember, that also means the zeros. Okay, so to find those, just set the function equal to 0. You can graph it, same thing. The square root of 3x plus 1 equals 0, so I will square both sides. Right, if I raise both sides to the second power, that'll eliminate that radical for me. Subtract 1 from both sides. Divide both sides by 3. -1/3. So plugging -1/3 into the function would give me 0, which makes that a root. Now remember, there's a good correlation between intercepts, x-intercepts, and roots. So if you find a real number 0, a real number root, then that's one of your x-intercepts. So that's an x-intercept. To find the y-intercept, you can just remember that y-intercepts have the x value being 0. So if I just plug in 0 into the function, that y value that's produced is the y-intercept. Three times 0 is 0, so we have the square root of 1. Square root of 1 is 1, so those would be my intercepts. Okay, really can kind of picture the graph from this, right? So 0, 1, and -1/3. So here's 1, -1/3 is about right there. Graph looks something like that. Okay, let's find the inverse. Okay, been a little while since we've done that. Remember, to find the inverse, I like to write it out as y equals the square root of 3x plus 1, and then invert my x and my y. Then it's just a matter of solving for y. So first thing I would do is square both sides. So x squared is equal to 3y plus 1. Subtract 1 from both sides. Divide both sides by 3. And so there you go. There's my inverse. And break it up into 2 fractions. Same thing. Okay, so there we go. That's my inverse function there. Okay, and then we want to describe the graph. And I think that's the last one here. So let's describe the graph then. Okay, and there's a few ways to think about this, but let me write out the function again. Just I like to have it as a reference. Okay, and so the graph is going to have the same graph as, if I ignored all this, the square root, right? So the square root of x. But there's some sort of transformation going on here. Okay, and so there's a couple of ways you could think about it. Let's just take it one piece at a time. Okay, there's 3x plus 1. This plus 1 right here would indicate a shift to the left 1. Then this multiplication times 3 on the x indicates a horizontal compression by 1/3. Okay, 1/3. It's always the reciprocal of that. Okay, and so let me give you a visual of what I'm talking about here. I think I have it. Here we go. Okay. So f of x equals the square root of 3x plus 1. Okay, so it's this, I'll make it red function here. And let's compare it to the square root of x. Okay. So you can imagine if you just look at a point here, like this point 0, 0. If we were doing the transformation we just described, we said shifted to the left 1, which would be here, and then compressed by a factor of 1/3, horizontally by a factor of 1/3. And so a third of -1 would be -1/3, which is where we land here. Okay, and so that's one way we could look at it. Yeah. Just to talk about that compression thing there, if we change that to, let's say, a 5, that'd be 1/5, right, or 0.2. Okay, so the bigger you make this number, the more it's going to compress it horizontally. Right, if you make this number smaller, let's say 1 or 0.5, look at that, it made it the opposite of compressing, right? Stretched it out horizontally. Okay, anyway, that was just to give you a visual. All right, enough of that one. Okay, so we're going to say f of x is the square root of 3x plus 1. Set that equal to x plus 1 and solve it. Okay, so the square root of 3x plus 1 equals x plus 1. Let's get rid of the square root on the left by squaring both sides. So that'll give me 3x plus 1 equals x plus 1 squared. Let me multiply x plus 1 squared out. Right, that comes from, just to quickly show you, that's x squared. That's 1x. That's 1x. That's 1. Those two together become 2x. There's my 1. And we already said this and this was x squared. I know you can multiply it out though, so I'm not going to spend much time on that. All right, so a quadratic, let's subtract 3x and subtract 1 from both sides. So I can have it equal to 0. So subtracting 3x will give me 2x minus 3x is 1x. 1 minus 1 is going to be 0, so that's gone. I'm left with x squared minus x. Factor out an x. The zero product property comes into play. X could be 0. X could be, or x minus 1 could be 0. Give me x is 1. Okay, so now with dealing with radicals, you should always go back and check to make sure your solution makes sense. So 0 and 1. Does 0 work? If I plug in 0, that's 0 plus 1, square root of 1, which is 1. 0 plus 1 is 1. I get 1 equals 1. So 0, good to go. Plugging in 1, 3 times 1 is 3, plus 1 is 4. So we're looking at the square root of 4, which is 2. 1 plus 1 is 2. They both work. I guess we're done with this section here.